from streaming video on the go to connecting with friends and family across the country, our daily lives are just powered by this incredibly advanced telecom ecosystem. It all feels so seamless, almost like magic, right? But have you ever really stopped to wonder how it all actually works? Okay, let's dive into this.
That is the big question, isn't it? Who are the architects behind this vast, invisible infrastructure that we rely on for pretty much everything? Well, the answer lies with a very specific group of companies that form the hidden backbone of our digital world.
These architects of connectivity, they're called telecom operators. They're the companies that design, build, and maintain the massive networks our devices are talking to every single second of every single day. So what do they actually do? Well, their job really boils down to three core functions. First, they provide the wireless service itself. That's the obvious one. Second, they build and manage all the physical stuff, the towers, the cables, the whole shebang. And third, they use something called licensed spectrum to actually get that data through the air to your phone. And don't worry, we'll definitely get into that last one in just a little bit. Here in the United States, the landscape is pretty much dominated by three major players. You see their names everywhere, of course. And what's interesting is that each one has a really unique strategy for connecting the country, especially now that we're in the era of 5G. And this is where it gets really interesting, because while they all provide connectivity, they are absolutely not doing it the same way. Verizon, for instance, has always focused on top-tier network performance. They made an early, aggressive bet on super high-speed M-Wave 5G for dense cities. AT&T, on the other hand, casts a much wider net, leveraging its long history to provide broad coverage for both regular folks and big business clients. And then you have T-Mobile. After they merged with Sprint, they basically hit the jackpot, getting a ton of mid-band spectrum, which allowed them to go all in on that sweet spot of both speed and nationwide coverage. Okay, so now that we know who builds the network, let's take a look at what they're actually building. It's so much more than just that cell tower you see on the side of the highway. It's a really complex end-to-end system, and it has several critical pieces that all have to work together perfectly.
So here's how it basically works. Your phone sends a signal to a base station, what we all just call a cell tower. That tower is then physically connected by super high-speed fiber cables, or backhaul, to the core network. Now, the core network, that's the brain of the entire operation. It manages everything from routing your calls to connecting you to the internet. All three parts have to be in perfect sync for it to work.
Hey, remember that word spectrum I mentioned a little while ago? Well, think of it as a set of invisible highways in the air all around us. And just like we have different kinds of roads for cars, there are different bands of spectrum for carrying our data, and each one has its own unique pros and cons. So, you've got your low-band spectrum. This is like the massive interstate highway system. It can travel for very long distances, and it's great at going through walls and buildings, which makes it fantastic for making sure you have a reliable connection, especially out in rural areas. It gives you coverage, but it's not necessarily built for top speed.
Next up is mid-band spectrum, and this is really the sweet spot. You could think of it like a major city artery. It offers this fantastic balance of really high speeds and pretty good coverage. This balance is exactly why it's become the absolute cornerstone for most 5G networks out there today.
And then we have millimeter wave, or MM-wave. This stuff is the super fast express lane. It can carry enormous amounts of data at incredible, mind-blowing speeds, but it can't travel very far, and it's easily blocked by things like walls or even leaves on a tree. This makes it perfect for really dense, high-traffic places like stadiums, airports, and busy downtowns. Now, these invisible highways aren't a free-for-all. That would be total chaos. They're a limited public resource, and here in the United States, they are managed and licensed by the Federal Communications Commission, the FCC. You can think of them as the traffic controllers for the airwaves, making sure everything is used efficiently and that nobody's signals are crashing into each other. So we have the builders and we have the highways, but what about the technology that actually makes the traffic, flow? Making 5G a reality requires some incredibly sophisticated engineering to make our connections faster, more reliable, and more efficient than ever before. Let's look at three key technologies that really make 5G so powerful. First, there's OFDM, which is just a super clever way of organizing the data signal so you can pack way more information into it without getting errors. Then there's MIMO, which uses multiple antennas on both the tower and your phone to send and receive data at the same time. It's like turning a 2-lane road into an 8-lane superhighway. Finally, there's beamforming, which is so cool. It acts like a spotlight, focusing the signal directly at your device instead of just blasting it out everywhere. This gives you a stronger connection and wastes way less energy. So, as you can tell, the system is complex and it's constantly evolving. But building and upgrading these massive networks is definitely not without its challenges. The operators face a number of really significant hurdles as they work to build the next generation of our connected world. Operators face some huge hurdles. Getting enough of the right kind of spectrum is a constant battle. The cost of deploying new equipment, we're talking fiber, 5G towers, is astronomical. And effectively covering vast rural parts of the country remains a huge challenge. And on top of all that, our collective demand for more and more data just keeps growing, exponentially. So to bring it all together, there are really three key things to remember. First, the US market is led by three major operators: Verizon, AT&T, and T-Mobile. Second, each one of them is taking a unique strategic path to 5G by using a different mix of that spectrum we talked about. And finally, all of this is powered by some incredible, mind-blowing advances in wireless engineering. And that brings us to our final thought. We've seen how we got to 5G, but our appetite for faster, more reliable data, well, it isn't slowing down. It really makes you wonder, as this demand continues to skyrocket, what new technologies and strategies will be needed to power the next connection? What will 6G and whatever comes after that truly be capable of?